recorded it last block, but you never know. Sometimes things go wrong and it's good to have a backup. We have calcium hydroxide. And if we look at a little periodic table over here, calcium is right about here. Okay, there is calcium. And I would like to know what type of element calcium is. So first of all, what I'd like you to think is what might I mean by type of element? Have a little chat with your neighbors about that. What could I mean by type of element? What do you think? That could be for sure. Yeah, yeah. That's okay. He said he went to his counselor. I don't know. Right? Okay, so the type of element we are looking at is a, what's one category we could put it in? It is a metal. And in fact, today, there are all sorts of other categories as well. Like you could say, is it an alkali metal? Is it an alkaline earth metal? But for today, the only thing we're concerned about is that calcium is a metal. And if we have a compound that starts with a metal, oh, by the way, I know this is the third time I'm doing it, so I might jump about a bit because I get a little confused about what I've already said. This little staircase here, what does it separate? The metals from the nonmetals. So our nonmetals are over here. Is that it for the nonmetals, or are there any more? Hydrogen. Hydrogen is also a nonmetal. The rest of them are all metals. If we have a compound that starts with a metal, we have a specific type of compound. Does anyone know what the types of compounds are? Chat with your partner, see if you can remember what are the different types of compounds. Anyone want to give me a type of compound? Yes, ionic. The other type is covalent. Do you know which type of compound starts with a metal? Those are ionic, okay? That's how we know that calcium hydroxide is an ionic compound, because it starts with a metal. I will say or NH4. Now, hydroxide isn't a single nonmetal. What is hydroxide? Does anyone remember the formula for hydroxide? Yeah, Isaiah. It's actually the opposite of an acid. It is a base, yes. And what two elements is it made of? Oxygen and hydrogen, hence the hydra for hydrogen and the oxide for oxygen. Okay, so hydroxide is OH minus. And that is made of two different elements. So it is called a polyatomic ion. Poly means many. Atomic obviously means atoms. So as long as you have two or more atoms, you have a, joined together, you have a polyatomic ion. In this case, you have an oxygen and a hydrogen stuck together to make a little polyatomic ion, hydroxide. What structure do polyatomic, or not polyatomic ions, do ionic compounds form? See if you can remember that. Have a little chat. Yeah. It is a crystal lattice. Yes, indeed, it is a crystal lattice. And now what I would like you to do is I would like you to draw a crystal lattice. See what you can remember. Take a crack at drawing it and then compare it with your partner. So once you've drawn a little crystal lattice, show your partner, show someone near you. Doesn't have to be beautiful. Because you know if I draw one, it's definitely not going to be beautiful. What should it look like? It's going to be a cube, okay? You don't have to draw it three-dimensional because that's pretty tricky. So drawing it in 2 dimensions is usually a good choice. What should it look like? A 3D square of alternating positive and negative ions. And what it's going to look like is you're going to have a big circle and then a smaller circle, a big circle and then a smaller circle, and then we're going to do the same thing on the row below it, just alternating. Okay. Now, if you didn't make them bigger and smaller, that's okay, not the end of the earth. And you can see mine is terrible. Mine looks awful. So I'm going to hopefully make it just a little bit tidier by letting you know that the larger ones are the negative ions and the smaller ones are the positive. If you got that backwards, it really doesn't matter that much at this point, so don't worry about it. Okay. But the key thing is that we have alternating positive ions and negative ions. Has anyone learned some words that mean a word that means positive ion and a word that means negative ion? Yes? Cation and anion, yes. If you have trouble remembering that, now this is not going to be on this upcoming test, okay? But it will come up later, okay? Cation and anion, if you have trouble remembering, what do cats have? They have paws, so cations are positive. Ah, okay. Now, for anion, you can remember it because you have A, so A for A, and then N for negative, ion. You have A, negative, ion. Or you can think it kind of looks like onion. And what do onions do? They make you cry, which is kind of negative, okay? So either way, they're not on this test, but they will be coming up in the future. So when we have our calcium and we have our hydroxide, which one is the cation and which one is the anion? Calcium is the cation and hydroxide is the anion. Because we have Ca, 2 plus, and OH minus, and I don't know what happened to that C. It looks really weird, so I'm going to fix that. There we go. Now, I am going to draw a box around this, okay, because I want to shrink it so that it is not such a pain to draw. I don't want to always be drawing positive, negative, positive, negative, positive, negative. It could take us all day just to do that. So I'm going to say, okay, here we have our crystal lattice, and because it's a crystal lattice made of ions, we will actually specifically, we can call it an ionic crystal lattice. And we are going to shrink it so that it is more manageable to draw, and we can draw many of them and put them in a beaker. Okay, so it's now going to become a tiny little square. You can imagine within that tiny little square, there's tiny little positive, negative, positive, negative. Okay, so there is our ionic crystal lattice, both up above and down below. Okay. CaOH2, solid, which is what we used, is a powder. So the solid particles are pretty small, yes? They're like just little dust particles, okay? It is made of many small crystal lattices. Each grain of powder is a small crystal lattice. So you can imagine that dusty kind of stuff we had yesterday. Each of those little white particles of dust is one of those little yellow squares, okay? And each of those little yellow squares contains positive, negative, alternating like that, okay? Atoms are really small. There's probably hundreds of ions within each of those little dust particles, okay? Maybe thousands, maybe millions, I don't know. Okay, particles like atoms and ions are really, I could go on, tiny, okay? Now we are going to take our calcium hydroxide powder and do what we did with it yesterday. We're just going to do it in pictorial form now. And we are going to put it into a beaker full of water. Okay, there's our beaker full of water. And within that beaker, it was very cloudy, yes? So we still had lots of, most of the calcium hydroxide stayed as tiny little ionic crystal lattices, okay? So these are small crystal lattices. Of CaOH2. And what that is those are the grains of solid. I'm not going to draw as many of them as we would proportionally have if your mixture looked like this, okay? Otherwise, it would just get too cluttered. Yes, it would get too messy. But what do those little crystal lattices do if we shine a light on them? So if I have a flashlight, and I shine the flashlight, what happens when it hits one of those little crystal lattices? It bounces back and gets scattered, okay? The light gets scattered by bouncing off the solid particles. What does that make it look like when the light gets scattered? Sorry? It appears white, but not only just white, because you can have like things that are other colors too, but it appears, the word that we usually use is cloudy, okay? So it's no longer clear. So cloudy is like kind of the opposite of clear, okay? So what has happened in here is that most of the solid particles those small crystal lattices they stay intact. So if you can imagine, within each of those little yellow squares is positive, negative, just like this, okay? This is floating around in the water. And the reason that most of them stay intact is because calcium hydroxide is not very soluble. It does not dissolve well in water, but they stay intact and they float around. I.e., you guys know what I.e. means? It means, in other words, okay? Not that you need to know this, but it is from the Latin id est, which means that is. In other words, that is to say, in other words. Okay, so that's where the IE comes from. You don't need to know that, but sometimes you're going to run across people writing IE, and it might be nice to know that it means in other words. So IE, we have these little small solid particles that float around. We have the solid particles are suspended in the liquid water. So IE, in other words, the solid particles are suspended in the liquid water. When you have solid, tiny solid particles suspended in a liquid, yes. What type of substance do you have? I heard a couple answers. And in fact, there are a couple different answers. Yes. It is a suspension, which is a specific type of heterogeneous mixture. Okay? Now, do you guys know what the prefix hetero means? It means different. So if you are heterosexual, you are attracted to people of a different gender. Homo means the same. That prefix means same. Okay, so if you are homosexual, you are attracted to people of the same gender. Okay? And just in case you're wondering, pan means all. And bi means two. So they all work. All those prefixes all have meanings, and they're all used in science. Okay? And in fact, cis and trans came from organic chemistry. When we learn a little bit of organic chemistry, I'll show you how they came from organic chemistry. I was so excited when I learned those terms. I'm like, they're from organic chemistry, which is not really the point, but I'm such a science geek. That was what got me like super excited about it. I'm like, anyway. So we have the heterogeneous mixture, and it contains clumps. This is how you can recognize one. Clumps. And if you're tired with this lecture, just imagine if you've done it 3 times in one day. Of different materials in different areas. Now the word clumps, it's one of those words that sometimes ELL students are like, what the heck's a clump? This is some weird English word. A clump just means a gathering of a particular substance, like a little, like I've got a clump of pens here, all the pens are together. If somebody pulled out a chunk of your hair, you would say they pulled out a clump of hair, okay? If you had a ball of dirt, you would say you have a clump of dirt, okay? So clump, it just means like it's all the same stuff all together, okay? So in our mixture, we have little clumps. These little crystal lattices are little clumps of solid surrounded by liquid area. So you see how we have different areas? Okay, so we have the solid area and we have the liquid area. Okay, so there we go. That is our suspension. And we're now going to draw this suspension again down here. La 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 la. With a little what you call them, crystal lattices, mini crystal lattices, all floating around in there. Okay, because we're going to now take this suspension and do just what we did with it in the lab. We are going to take it and we are going to pour it into what do you imagine that is? That is a funnel. And in the paper, in the funnel, we have put some filter paper. And the filter paper has holes in it. small holes. I would like you to imagine that the holes in the filter paper are about this big. Okay, can you hold up your hands like that? That's about the size of the holes in the filter paper, at least our imaginary filter paper, okay? I can't do this and hold this at the same time, so you're gonna have to imagine the other half of the hole. Can you imagine that? The other half is still there, okay? Now, we're pouring the liquid through the funnel, and here comes the little mini crystal lattice. Does it go through the hole? No, because it is too big, okay? So the little mini crystal lattices get stuck on the filter paper because they are too big to fit through the holes. Too big to fit through the holes in the filter paper. But if you recall, we had like these little circles. Don't forget that they actually represent, oops, that should be a negative. Whoops, negative, positive, negative, positive, positive, negative, positive, negative, negative, positive, negative, positive, positive, negative, positive, negative, negative, positive, negative, positive, negative, positive, positive, negative, negative, positive, negative, positive, negative, positive, positive, negative. Sorry, that was too much fun. Okay, anyway, don't forget that these little yellow squares actually represent that, yes? So when I draw now a water molecule, okay, the water molecule how does it compare in size to our little mini crystal lattice? It's small, okay? Okay, so here's our crystal lattice, and remember, it was too big to go through the hole. But if I have a water molecule, I like these to represent water molecules because they kind of look like they have like an oxygen and then two little hydrogens sticking off of them. Yes? How about the water molecule? Does it fit through the hole? Yes, it does, because it is much smaller than the crystal lattice. Yes? Now, in order for this to work on our diagram, I shrunk my mini crystal lattice into those little squares. I am also going to shrink my water molecule so that it is just now a little red dot, okay? That's now H2O, because if I'm gonna shrink one thing, I have to shrink the other thing so that they are now there together. And so in this beaker, I now don't just have those, I have little water molecules. Now, to be fair, if I were to draw as many water molecules as they really were, it would just be completely red, okay? So I'm only going to draw a few so you can see how big they are in relation to the little mini crystal lattices. So when we start putting the water can fit right through, okay? So the water is small enough to fit through the holes in the filter paper. Yes. So there goes the water. So down below the funnel, and I haven't left myself much room down below the funnel, so I'm gonna be like, okay, it's going over here now. All right, we end up with our beaker. And now, instead of looking like this, it looks like this after it has been through the funnel. Yes? So what do I now have in my beaker? I now no longer have the little mini crystal lattices. Now I just have what's left? Water. Okay, and like I said, that would just be like completely red if I drew all of them. But is water the only thing that is in that filtrate? Remember, the filtrate is the solution that is left after filtering. Was water the only thing in that beaker? No, how do you know it wasn't the only thing in the beaker? When I blew into it, what happened? It went cloudy, right? I just blew into it. Does water turn like this? Does it turn cloudy when you blow into it? No, it does not. So there had to be something else in there. What else was in there? Any guesses? Yes. The calcium hydroxide. Yes. But it had to be small enough to get through the filter. Yes? This was not small enough to get through the filter. How could I make it small enough? What could I do with these? I could break each individual ion off. Now, of course, these are like welded on here, so I can't do it. But if I was to pull off one of these little ions, would it fit through the hole? Yes, it would. So what happens is when the calcium hydroxide dissolves, some of the calcium hydroxide dissolves. And so what we end up with then, and this is where people were like, you know, rolling their eyes at me and they're like, are you serious? We're moving over to the right. Why did you not give me more paper? Anyway, now what we have is we have the ions floating around, individual ions floating around separately from one another. Now, in order for my picture to work, I had to shrink my mini crystal lattice into a smaller little square. I had to shrink my water molecule into a little red dot. What should I do with my ions to fit them in my picture? I should also shrink them. So I'm going to take my ions, I'm going to take my hydroxide, and I'm going to take my calcium, and I am going to shrink them. And just so they look a little bit different, I'm going to draw them as little tiny circles instead of filled in dots. But now it becomes apparent that each of those little tiny individual ions will fit through the holes in the filter paper. So up here, I don't just have little mini crystal lattices in water, I also have some individual dissolved ions. These guys are individual ions. Will they go through the filter paper? Yes, they will. So now, down here, that's what's in here. Okay, we have water molecules and we have little dissolved ions. Are those dissolved ions big enough to scatter the light? No, you can see there's no light scattering going on. The light is going straight through. And if it's not big enough to scatter light, it's not going to appear cloudy. It is going to appear clear. Therefore, it is not a suspension. Rather, it is a solution. Whoa, that was a crazy yes. And what type of mixture is a solution? Homogeneous. Phew. Okay. Thank you guys for paying attention to that really long and involved lesson. Did it help with some of those concepts? Okay. Your homework is to finish the lab. The one thing I've not really gone over is the very last question on the lab. We can talk about that tomorrow. So finish everything up till the last question of the lab, and we can talk about that one tomorrow before you hand it in. Okay? So that is your homework, is to finish the lab, except for that last question. And if you sort of zoned out on this and you're like, oh my God, that was just way too much, maybe on the weekend you can put me on like 1.5 times and watch it again. I find it actually hard to watch YouTube videos on anything slower than 1.25. Hi. Measurement? Yeah, sure. Measure B. There we go. There you go.